Christmas Day, 2021. While families exchanged gifts, the world's scientists watched a different kind of present, the launch of the James Webb Space Telescope. On a launch pad in French Guiana, a rocket stood ready, carrying decades of dreams and effort. The stakes were sky high. Webb was heading 1,000,000 miles from Earth, far beyond any hope of repair. The countdown began. Engines thundered and the Ariane 5 rocket soared, carrying its precious origami-folded cargo. The world watched, breath held as the telescope endured the violence of launch and the cold of space. Over the next month, Webb began its intricate unfolding, a slow, high-stakes ballet. First, the tennis court-sized sunshield unfurled, 5 layers thin as hair, to protect Webb's sensitive instruments. Then, the golden mirror opened. 18 hexagons forming a single, massive eye. Each step was a potential disaster, but each step worked. Finally, Webb reached its destination, settling into orbit beyond the moon. Its instruments cooled to just above absolute zero, ready to peer deeper into the universe than ever before. Webb's mission: to look back in time, further than any telescope before it, to see the first stars and galaxies flicker on. Humanity's new eye on the cosmos was open. A new era of discovery had begun. The hopes of a generation of astronomers rode on this moment. The world's most powerful time machine was ready for business. It was designed to reveal the universe as we had never seen it. The journey itself was part of the mission. Every moment was critical. The telescope's unfolding was a slow, deliberate dance in the void. The sunshield and mirror were engineering marvels. Each success brought us closer to unlocking cosmic secrets. The universe was about to reveal its oldest stories. The greatest Christmas gift, a new window into the beginning of everything. What makes the James Webb Space Telescope so special? It's not just another telescope, it's a new kind of eye. Hubble, its famous predecessor, sees mostly invisible light, what our eyes see. But the universe is expanding, stretching ancient light into the infrared. Webb is built to see this invisible, stretched-out light, heat from the dawn of time. To do this, it must stay incredibly cold, shielded from the sun by its giant sunshield. At nearly -233 degrees Celsius, Webb can detect the faintest whispers from the early universe. Its mirror, over 6 meters across, collects more light than Hubble ever could. Think of it as a giant bucket catching cosmic raindrops. More light means seeing farther and fainter. Webb peers into dusty clouds where stars and planets are born, and looks back to the edge of cosmic time. It's not a replacement for Hubble, but a successor, pushing beyond what Hubble could see. Hubble showed us a universe full of galaxies. Webb is our time traveler, built to answer the biggest questions. How did the first galaxies form? Where did we come from? Webb is our tool to find those answers, hidden in ancient light. Its combination of size, sensitivity, and infrared vision makes it the most powerful space observatory ever built. Webb's mission: to reveal the universe's earliest chapters. It's a leap into the unknown, building on Hubble's legacy. The universe's secrets are written in faint, red-shifted light, and Webb is finally able to read them. With Webb, we're not just looking farther, we're looking further back in time than ever before. The telescope is humanity's new eye on the cosmos. It's ready to show us where it all began. The next giant leap in our cosmic journey has arrived. The universe is about to get a whole lot bigger. Imagine the universe as a vast, dark room, no stars, no galaxies, just darkness after the Big Bang. This was the cosmic dark ages, a time of cooling hydrogen and helium. Scientists have long wondered, how did the first lights turn on? When did the first galaxies assemble? To see this era, we must look incredibly far and thus, back in time. Webb is designed to see light that's traveled over 13.5 billion years, revealing the universe as a cosmic toddler. Before Webb, our view of this era was blurry, just theories and simulations. We expected to find a few big, bright galaxies forming slowly. Webb was sent to find these pioneers and confirm our models, but the universe loves surprises. Webb pointed its golden eye at a patch of empty sky, collecting every faint photon. What it found was not what anyone expected. Instead of a few giants, it saw something far more interesting. The cosmic dawn was about to be revealed not as we predicted, but as it truly was. Science thrives on the unexpected. Webb's first deep look would challenge everything we thought we knew. The universe's first light was about to shine through the darkness. A new chapter in cosmic history was opening before our eyes. Webb's first deep field images were breathtaking, but the real shock was what filled the darkness. Thousands of tiny, faint smudges, each a galaxy, crowded the image. These weren't the large galaxies we expected, but tiny, ancient ones. They existed just 300–400 million years after the Big Bang. The universe had built galaxies earlier and in greater numbers than anyone predicted. Astronomers call them little red dots, hundreds of times smaller than the Milky Way, some with just a few million stars. These were the seeds, the building blocks from which all larger galaxies grew. The discovery was a bombshell, forcing scientists to rethink how galaxies form. How could so many galaxies appear so quickly? The universe was far more efficient at making galaxies than our models allowed. It was as if the recipe for galaxies was simpler and faster than we thought. This finding sent astronomers back to the drawing board. Science advances when new observations force us to rethink old ideas. Webb's images showed the universe's first sparks of light. The cosmic darkness was filled with countless tiny galaxies. The story of our origins just got a lot more crowded and a lot more interesting. For decades, scientists believed galaxies formed slowly small clouds merging over billions of years. The leading theory, the hierarchical model, predicted a few big galaxies in the early universe, with most of space still empty. But Webb's discovery of thousands of tiny galaxies flips this idea. Galaxy formation wasn't slow and rare, it was rapid and widespread. The early universe was a field of blooming flowers, not a few big construction sites. The conditions must have been perfect, dense, cool gas collapsing quickly into stars. Instead of building a castle brick by brick, the universe sprouted countless small workshops, all making stars at once. This is a fundamental shift in our thinking. Mergers and collisions still matter, but the starting point was a swarm of small seeds, not a handful of giants. We're not throwing out the old recipe book, just rewriting the first chapter. The beginning was far more frantic and crowded than we ever imagined. Webb's findings force us to update our cosmic story. The universe's first galaxies were everywhere, forming fast. Our models must now catch up to the reality revealed by Webb. The early universe was a cosmic rush hour, not a sleepy dawn. What did these tiny, ancient galaxies look like? They were simple, irregular blobs of stars and gas, nothing like the grand spirals we see today. Made almost entirely of hydrogen and helium, they were chemically primitive. Heavier elements like oxygen and carbon hadn't yet been forged in stars. The stars inside were likely massive, hot, and short-lived, burning out in just a few million years. The early universe was a place of fast-living, bright-burning stars. By studying these primitive galaxies, we see the universe's starting conditions. They are the ancestors of galaxies like our Milky Way. It's like finding a photo of your great-great-grandparents, familiar, yet so different. These tiny galaxies are our cosmic family album. They show us where we came from and how much has changed. Webb lets us witness the universe's humble beginnings. This discovery changes our understanding of the universe's history. The early universe wasn't quiet, it was bustling with star and galaxy formation. Dark matter, the invisible glue of the cosmos, must have played a key role, pulling gas together efficiently from the start. The rapid rise of so many small galaxies suggests dark matter halos were ready-made scaffolds. This also helps explain cosmic reionization, the process that cleared the universe's fog. With so many tiny galaxies, there was enough ultraviolet light to make the universe transparent. It wasn't a few big lighthouses, but millions of tiny candles lighting up the cosmos. The transformation of the universe was a collective effort. The universe was built by a swarm of cosmic dwarfs, not just giants. Webb's discoveries reveal a more democratic, dynamic cosmic dawn. The story of these tiny galaxies is our story too. Every atom in your body except hydrogen was forged in stars within galaxies like these. By studying the birth of the first galaxies, we trace the first steps that led to us. Webb lets us see the echoes of our own creation, written in ancient starlight. The universe was creative and fertile from the very beginning. This discovery fills a crucial gap in our cosmic history. We're looking at light that began its journey before Earth or the Sun existed. It's humbling, reminding us we're part of a vast, ancient story. Webb is more than a machine. It's an extension of our curiosity. It lets us ask the universe where we came from, and listen for answers in the faintest light. The journey from cosmic dawn to today is now visible. We are witnesses to the universe's first moments. What's next? Webb's discoveries are just the beginning. Astronomers will use it to study these ancient galaxies in detail, breaking down their light to learn their secrets. The hunt is on for even older galaxies, closer to the first stars. Each new image pushes us deeper into unexplored territory. Understanding the first galaxies will reshape our knowledge of dark matter and stars, and even the origins of life. The universe is a connected system, one discovery leads to many more. Webb's journey has just begun, and it's already rewriting our cosmic story. For the next decade, it will reveal the universe's secrets, one photon at a time. We live in a remarkable age, able to watch the birth of the cosmos from our own front row seat. The next chapter is being written now, and we're all part of it.